Hi everyone, welcome to this session. My name is Samir, and today I'm going to be sharing with you a real world use case of how we at Baltic tackled one of the most challenging problems in modern SaaS developments, building a truly global multi region platform that serves millions of users while maintaining consistency, compliance, and performance. Before we move on, just a little bit about me. So my name is Samir Dev. I work as a principal engineer here at Find. I've been here for over 4 years, and I've had the privilege of leading Baltic's global infrastructure expansion, which is what exactly we'll be discussing today. So before we start, just a little bit about what exactly is Baltic. So Baltic is a modern enterprise-grade data platform. So you can think of it as a powerful cloud-based multi-region platform designed to streamline business operations through advanced automation and data management. Our vision is very simple: to simplify work and make operations easier for businesses of all sizes and industries. We like to say, what we like to say usually is one platform for all your data and automation needs. Moving on to some of the core features that Baltic provides, uh, we have six, seven, close to I think eight or nine core features. I'll be explaining to you a bit about the top six one. So one of the biggest core features that we have right now is workflows, which is basically a visual no-code workflow automation that help businesses around the world build and automate processes 10x faster. Another one of the features that we have is called as pipes. So pipes is basically a CDC kind of a framework that allows you to capture real-time data from all of your different databases, and instantly sync it across any kind of global data warehouse that you may use for business analytics or real world querying in order to drive data driven insights. The other things that we have are integrations. So we have over 250 pre-built connectors for you to connect out with the freeware tools. Maybe you are on AWS, maybe you're on GCP, you like to use Azure, or you have Gmail, you have OneDrive, you have Microsoft Teams. Anything and everything that you can think of can easily be connected within the platform, and it is already pre-built. It only requires a simple click and an integration from your side to get it up and running on Baltic. Uh, Moving on to serverless compute. Serverless, essentially, as the name says, allows you to deploy your code without having to worry about infrastructure scaling and any kind of management. That is entirely handled by the global infrastructure built at Baltic. It allows you to build your applications from the ground up without having to worry about how it will scale, how it will essentially serve millions of users, and all that just at a click of a button. So another feature that we have is called as Baltic Tables. So Baltic Tables lets you organize, manage, and store your data in a secure and compliant manner directly on Baltic without having to worry about, again, scaling and how you manage your database, how it gets connected to you, how well it handles all the requests coming it to you on any given scale. So this allows you to make every application that you build as part of your workflows or your serverless stateful. The sixth one that we have is streams. So streams allows you to capture real-time analytics and event processing for continuous insights. uh, the simplest use case for this would be, let's say you have a website, you want to understand how exactly are your users interacting with your website, how do they proceed about, do they come on the landing page, where do they go from the landing page, what kind of products are your users liking, what exactly is your users behavior looking like. So streams allows you to capture the entire thing in a single go within a single platform. So as you can see, Baltic essentially allows everybody from every nature, be it an engineering background, be it a PM background, be it a TPM background, or a data analytics background. We have something for everybody, which allows you to combine your entire business use cases in a single platform itself. Good. Moving on to Baltic's current scale. So Baltic redefines how businesses monitor, analyze, and act on operational data in real time. With our advanced data pipeline and event-driven architectures, we ensure precision, speed, and resilience at scale. So the stats that I'll be sharing with you right now are basically our year-to-date stats for 2025. We have processed close to 8 billion automation actions via our no-code, low-code workflow frameworks. At any given point in time, we process tons and tons of data via CDC, via serverless, or via streams, and 200 terabytes is what we have processed in this current year. Close to 15 billion stream events have also been processed onto the platform, and at any given month, we handle close to 1 billion requests from the outside world that our current customers are using. So this is the current scale that we are operating at, and essentially, in order to manage such a huge scale, we need something that is resilient. We need something that is, it never goes down. We need something in order to ensure that we are compliant in our SLAs, and we are never actually down as a platform. Right. So, what was the use case as to why we chose Yugabyte, or what was the use case that you're looking for when we were building this platform? So, the objective of building on a database was that it had to be 100% open source. It had to be cloud native, because right now we are on GCP, but we'll also migrate on to AWS. We'll also migrate on to Azure, and all of these can then get built in within a single platform, or can be served as part of a single offering. We want it to be high performant. So, as shared in the previous slide, the scale at which we currently run on is very huge. So it cannot be a very small database that handles everything. We need it to be highly performant. We need it to be compliant in terms of latencies. We need it to be performant in terms of speed and accuracy and asset compliance. A distributed SQL DB for global internet scale applications. Now, why do I keep saying global and distributed SQL? Is because Baltic as a platform is multi-region in nature. So we have two regions that are live right now. A third region is in the works. So we are right now live on Asia as well as United States. Europe is another region that is right now, being planned for, and it will be live in a couple of weeks. So this is the inspiration, or this is what we were looking for when it came to a database in order to handle our entire platform. So before we move on, let me just help you understand what it takes to go truly multi-region with any given database. So going multi-region as an application, or as a SaaS provider, isn't just about deploying servers in different location. There are four business critical requirements that you need to fulfill in order to make any application truly multi-region or truly global. So first of all, you need to have low latency access. Our global customers expect sub-millisecond response times, whether they are in Europe, America, Asia, or any other region. So as we often say, our customers expect a snappy response regardless of their location. So the next point is data sovereignty. With customers in the EU, in the US, and in Asia, regulatory compliance required keeping certain data within specific geographic locations in or within specific geographical boundaries while maintaining a unified global platform. So it cannot be that a user has registered in the Asia region and their data is only accessible in the Asia region. Let's say my business now tries to expand from the US to the Asia region, or maybe from the Asia to Europe region. So anything that has happened in the Asia region should also automatically be replicated, or should also automatically be available in my EU region. I cannot keep on saying to users that no, you are switching a region, now you have to keep on signing or keep on inviting your teammates to other regions as well. So all of this has to be global, but still the entire sovereignty has to be maintained. So highly available is another point that is quite required when it comes to enterprises that use Baltic. So enterprise SLAs require 99.99 uptime with regional failure resilience. A single region outage could impact our global service availability. So if Asia goes down, it shouldn't be that anything that was running in the US or in the EU also has to go down. So that boundary, or that bracket, has to be maintained. And the last part is definitely horizontal scalability. So our data has been growing at a pace of about 10x on a year on year basis. We needed a database that was scalable enough that could horizontally be scaled across regions without compromising in performance. So let's say if I'm sitting in the Asia region and I see that a lot of traffic income is coming in the Asia region, I'll only scale out Asia without having to worry about what happens to the EU or the US regions. So basically, these aren't just technical requirements, these are business imperatives that would determine our success in the global market. So choosing the right database is actually not just an option, but a necessity in this point. So this brings us to a critical question. Why did we specifically choose YugabyteDB for Baltic? Cool. So Baltic's database requirements were that it had to be a global data distribution with low latency access across regions. There had to be strong consistency and transaction for transactional data. Horizontal scalability is a must for growing data volumes. Regional data compliance, as I said, you have SOC 2, you have GDPR, so all of those had to be maintained as part of the entire global platform. We also wanted an entirely Postgres compatible database for all our existing applications to work as is without having to move, or without having to do any kind of breaking changes within our applications. And the last part was that it had to be cloud native and fully open source. So, given all these considerations, Yugabyte is one of the databases that stood out in our evaluation with this comparison chart that you can see over here. While traditional RDBMS and NoSQL solutions had significant limitations, Yugabyte excelled across all dimensions. Global distribution, SQL compatibility, horizontal scaling, performance, data sovereignty, and operational simplicity. The three key decision factors that seal the deal was seamless migration. So Yugabyte is entirely Postgres compliant, which made sure that any of the applications that we were running before migrating to Yugabyte worked as is, and Yugabyte worked as a drop-in replacement for us. Performance at scale. So Yugabyte maintained consistent performances even with 10x the data growth that we have been seeing over the year during our evaluations as well as in the current production environments. TCO reduction. So we achieved a 40% lower total cost of ownership compared to other alternatives, which we again had to self manage or which we had to deploy to other regions and then do the entire management ourselves. Yugabyte does this quite seamlessly. We use a single binary in order to run the entire global database, at least for Baltic. So let me explain to you one of Yugabyte's most powerful features that helped us solve our data sovereignty challenges, which is geo-partitioning. So geo-partitioning allows us to pin specific data to a different geographical location based on the policies that we define. So this essentially allows us to have row-level control over data placements and ensures data residency compliance, reduces cross-region latency for local data. Let me walk you through one of the steps of how we can achieve this via Yugabyte and what exactly is the step-by-step approach. So first of all, what we'll be doing is essentially, you can just look at the implementation example that will give you a very good gist of exactly what is happening within geo when we enable geo partitioning within Yugabyte. So what we'll do first of all is create a main database called as customers. So and we'll essentially partition it by the region column. Now let us use list partitioning, which gives us explicit control over where the data essentially goes. Once we have done that, what we'll do now is basically create two different partitions, and on the basis of the column that we want to partition by and the value that we want to partition by, we'll essentially drop it, or we'll basically place it across different geographical locations. So in this example that I'm showing to you, what will happen is, even though customers is a single global table that is accessible across the entire platform, it is still we are still following data residency due to the partitioning that has been done over here. So what happens is, once I create a table, I then divide it into multiple partitions. Each partition depends on the basis of the region in which I want to store that data in. So what happens in customer underscore us partition is that anything where the region is us, all the data is specifically going to go and get resided in the us region. The same happens for asia region as well. So everywhere, wherever I am adding the constraint, as you know, the user is coming in from asia, their data residency always going to happen within the asia region itself. Now since customer is a global database, it doesn't matter if I insert from the US region or from the EU region or from any other region. But if I say that, you know, this user is from the Asia region, it will automatically reroute my request and automatically store my request, or automatically store the data that I am adding in my query to the appropriate given region. So this allows me to make sure that no matter what region I am querying from, or no matter where I am, you know, trying to add users from, it will always get stored in the user specified region. So what are the benefits that this gives for Baltic? First of all, definitely compliance. So user data stays in the user's region, even though the user goes from asia to us to asia, europe to asia, or any other region, so to speak, their data always resides in their preferred location. uh, the next part is performance. 65% reduction in data layer access latency, because now when I switch my region, I don't have to keep on going to my primary region, be it asia, be it us, in order to get any user data. I can specifically just try to understand where the user is querying from, or what is my user's primary location, and then add in that partition key for my query, which allows me to fetch data directly from my local regional database or from my local regional shard. Again, the next point is flexibility. So instead of having to manage multiple databases for every region and for every specific module, I now have a single database that is able to handle all of my users data, all of my platforms data in a single get go. So this makes operational simplicity. It makes management very simple. I don't have to, you know, monitor multiple databases, or I don't have to uh, understand what is happening exactly in which database. I now have a global view which I can directly see at any given point in time in order to understand what's exactly happening within my platform. Boltic's current setup. So right now we leverage a single global database, which is self-hosted, and it spans across multiple cloud regions. So we are live in, as I was saying, we are live in Asia and the US region. Europe is something that we are currently planning, and it will be live in a couple of weeks. So each region has three or more nodes for HA, which is high availability, and every node or every region has a replication factor of 3. So even if two of my nodes go down, I still have a copy of it in one of the nodes. So that allows me to not only have global resilience but also regional resilience. So some tables are located only in the primary region. So let's say something like RBAC is not specific to a region, it is always going to be global in nature. So that is always located in our primary region. In our case it is Asia. So for fast access to all of these co-located tables or all of these single region located tables, what we have done is we have created a read replica in all the other regions. So this allows us to first of all have access to uh, the primary region's data in a very fast manner without since a read replica essentially stores the entire data within its premise. There is a little staleness, but that staleness again can be manually changed, or that staleness can again be fixed by changing flags within the your query parameters or within your read replica setup, in order to tell Yugabyte that 5 seconds is the maximum staleness that I can have. Once the 5-second boundary is reached, you go and get me the latest data. So that allows us to make our read replica tweakable, in order to decide what data can be served from a stale copy and what data has to always have a fresh copy for it. The architecture supports fault tolerance, compliance, and regional autonomy. So as I was saying, all of this is, even though it is global, it is still very much strictly regional, at least in the essence of the platform. So that allows us to make sure that anything that is happening within the Asia region only happens within the Asia region, and anything that has to go global essentially gets global via read replicas. So this setup essentially allows us to support multi-cloud and hybrid deployments. So one of the plans that we are also working on is moving on to AWS. So in the future, if I have to either add a new region, not in GCP but in AWS, this will give me a lot of flexibility, since all I have to do is connect my AWS and GCP regions and then add a 3-node setup for another region in AWS and then connect it to my existing cluster. This makes sure that I am cloud native forever. It doesn't matter if I'm sitting on prem, it doesn't matter if I'm on GCP or on AWS. I can essentially run Baltic as a platform across all my regions or across all my cloud providers or data centers without having to ever worry about vendor lock-in. Since we have a self-managed gigabyte, that allows us to tweak and play around with it in order to make it relevant and in order to make it fast for our platform or optimized for our platform. So one of the things that we have done in order to reduce the cross region latencies is that we have introduced local read replicas in each region. Data is always geo-partitioned across prime majority of the tables, unless it is something that, as I was speaking, has to go around globally. uh, Query optimization is something that Yugabyte very beautifully allows us to do. So they have explain and cost, which allows us to understand if a query is coming in from one region, how is it getting interacted within its region, and how does it interact with the entire global system that we have built. So this allowed us to not only understand how a query is going to be running or how exactly is it performing, but where is it actually getting the data from. So this allowed us to optimize indexes. This allowed us to essentially understand if a user is coming from one of the primary regions or from one of the secondary regions, how will they interact with the platform, and how do user data or global data get shared or get accessed from other regions as well. And again, the last thing is connection pooling. So one of the things that Yugabyte also has is a built-in connection pooler, which essentially sits in top of your cluster or your node, and that allows you to have built-in connection management, which is again quite a good feature, since we didn't have to essentially use something like PG bouncer or a load balancer in between our clusters, as Yugabyte again has built-in connection pooling. Yeah, so that was about latency reduction strategies. Moving on to how we can achieve very high throughputs with Yugabyte. So after playing around with it and after experimenting a lot, what we have understood is that in order to improve throughput, All we need to do within Yugabyte is just add nodes. So the more the number of nodes you have in a given region or for a given database, so to speak, you can theoretically achieve a very high throughput. So the graph that you see on your lower right hand side essentially is transactions per second for a given type of node combination. So if you have something like a single node within a region, you easily get 1,000 transactions per second. But let's say you have to scale it to maybe 10,000, 15,000, 20,000, or 30,000 transactions per second. All you need to do is add more nodes. This allows the system to essentially distribute workload across multiple nodes. And not only does it help you achieve high throughput, but this also helps you, balance out the load in a given single region or across regions. Another is workload isolation. So as I was talking about having a separate reader instance and a writer instance across regions, this allows us to not only have fast writes but also faster reads for tables that are primarily located in a single region. Optimized indexes. So as I was saying, given that Yugabyte has a very beautiful explain and cost optimization algorithm built in within the system, it allows us to understand how a given query or how the query planner is essentially interacting with the database in order to find the most optimum path, which not only helps you tune your queries but tune your setups as well. And batch processing, Yugabyte is definitely very good for batch processing. You can just throw in any amount of data at it and it will easily be able to churn it in order to store it, read it, or write it. So that is definitely one of the plus points as well. Compared to other databases, there's a reason why we went out with Yugabyte and not other distributed SQLs out in the market. For first of all, Yugabyte gives us complete Postgres compatibility, and other solutions like Cockroach or Citus or Cloud Spanner and Scylla offered very partial support with different SQL dialects. So some did not have support for the indexes that we are trying to create. Some did not have the appropriate DDL and DML commands still supported within their platforms. And Yugabyte, uh, as opposed to other platforms, provided seamless integration with no modifications whatsoever. Coming to data ownership, others had limitations and required enterprise only features. Yugabyte gave us complete control over our data, which was definitely a plus point for us. And coming to operational simplicity, while others required a little bit more complex setup and moving parts with higher spec machines, Yugabyte essentially offered easy self-managed setup through Yugabyte D, which is a single binary that can be used in order to spawn your entire Yugabyte cluster at a given go, or a managed version of Yugabyte can also be used on Yugabyte Cloud. Moving on, let's see what our leadership has to say about this transformation. So Amboj Goel, who is our director of engineering, puts it perfectly. He says that with Yugabyte, Baltic is able to deliver a global SaaS experience that feels local. It feels fast, it feels resilient, and compliant everywhere we operate, which is quite true in every sense. And the success has actually been so significant with Yugabyte that Jigar Davda, our chief technology and product officer, notes that Yugabyte's success with Baltic has led us to adopt it across product lines as well. And its cloud native scalability and resilience have raised the bar, which is quite true because we have also started using Yugabyte in not just Baltic but a few other internal platforms as well that are essentially being built for this global scale and for enterprises only. So this isn't just about a product anymore. Yugabyte has actually become a standard for distributed data management across fine. Coming to the end of this session, let me just summarize a few key takeaways from our journey. So, global database or global scale requires more than just geography. You need true data sovereignty, consistent performance, and seamless operations across regions, which is quite difficult to achieve if you don't have, the appropriate infrastructure in place for the same. Postgres compatibility matters, at least for a platform like us. Postgres was something that we have been using extensively, and being able to migrate from a regional setup to a global setup without having to do a single line of code change is actually truly commendable. Geo-partitioning is a game changer. So, row level data placement control solved both our performance and compliance challenges in a single go. Operational simplicity at scale. Yugabyte's cloud native design reduced our operational overhead while improving reliability as well. And linear scalability works. We have proven that we can scale horizontally without performance degradation thanks to Yugabyte. If you're interested in learning more about Boltic, visit us at www.boltic.io, or give us a star on GitHub at github.com/baltic.io. Thank you for your attention. I'm happy to take any questions about your journey with Yugabyte and building a global scalable SaaS application.